So here's the last hardcore slide of this lecture. What's shown here is actually the water mass structure in the Southern Ocean, and also processes that actually modify the structure. Okay, so let's have a look at it. This is a TS diagram. On one axis is temperature, on the y-axis. Okay? And on the x-axis is salinity. And this graph here summarizes the entire structure of temperature and salinity, water masses in the Southern Ocean. So you print it out, put it over your bed or on the ceiling, look at it, and we must summarize. So for example, if you're you start at the surface of the Southern Ocean, and we are looking at this black curve. This is the water mass. As you go from the surface into the depth of the ocean, it becomes colder. So all that happens is you move downward in this diagram, from the surface to the bottom. Yeah. All right. What does change is the salinity. For example, at the depth of 1 kilometer, there is a minimum in salinity, and this you can identify the Antarctic immediate water. And this water is formed near the Antarctic divergence. We talked about these zones, which is between the polar front and the subantarctic front. Okay, the zone which is the immediate water. It pumps water into. Here, so we have North Atlantic. This can be identified through a maximum in salinity here at this depth, below between 2 and 3 kilometers in water depth. And then it gets colder and a little bit less saline or so, but this one is. Again, we have a connection to the shelf. Because shelf, there's the formation of very saline and old water in these coastal polynyas. Salinity increase from freezing creates this water directly connected. So while the time scale of the deep circulation in the ocean is very, very, very slow, very long time scales there, the connection between the shelf and bottom water is much shorter. So as I said, it happens every year during the winter season. Pulses, slope convection, and they are sensitive to the upper ocean stratification. They can corrupt it, this pulse. You melt too much ice, you add too much stable stratification to the upper ocean, it might interrupt the formation of. Okay, so let's finish off. Key understanding question. Which ocean has the roughest wave climate? What is significant wave height? What's the typical significant wave height of waves in the Southern Ocean during winter time? What role does the wind stress curl play in the Southern Ocean? How is the Weddell Sea polynya formed? What keeps it, this region, ice-free? How can you trace Antarctica? And what are oceanic fronts? Okay, so quite a number of questions. And the next lecture we will talk about Arctic oceanography. Also involves sea ice. Also involves meltwater, low salinity. Okay, so thanks for watching. And right, see you.